Hello. So I will go over quiz 11 today. Okay. So first question. Suppose an analyst takes a random sample of 5 recent truck shipments made by a company and records the distance in miles and delivery time in days that the shipment was made available for pickup. So the observations are as follows. So 5 observations, distance and time, right? Determine the covariance between the two variables. Use the sample covariance formula. So straightforward question. I gave you 5 observations on 2 variables and you calculate the covariance. Okay, so this works like you need to go through 3 steps. So I'm going to denote distance as x and delivery time as y. So first, you need to calculate the averages of x and y because we need averages to calculate the deviations. And in second step, you have to calculate the deviations for each variable and then multiply those deviations, okay? Multiply across variables. So that will be the cross product of the deviations. And finally, the covariance is the average of the cross product of the deviations. That's the definition of the covariance. And especially in this case, we are using the sample covariance formula. So when you calculate the average, the denominator is n-1. I kindly showed you here. Okay? So then let me show you how to do this. So step 1, calculate the average. Straightforward. Just add 5 numbers and divide by 5. Then the average distance is 600 miles. Average delivery time is 2 days. And then from here it gets more complicated. We are going to calculate deviation of x by subtracting 600 from each of the 5 observations of distance, right? So x observations are copied here and subtract 600 from them to obtain x deviations. Similarly, y deviations are these observations minus 2, right? So you use x variable information to calculate deviation x and then the other variable for y deviation. And then multiply. So 0 times something, 0, and 385, 940, 0, 360. So we obtain 5 cross products of the deviations across variables, right? So as you can see, 2 are 0 and 3 are positive. So easily you can tell the covariance would be positive. Of course, we need to calculate the average of these numbers. So given the cross product, 5 values for the cross products, we are going to calculate the average. So sum 5 numbers and divide by n-1, not n, because we are using the sample version formula. So denominator should be 4. Then the covariance should be 421.25. That is how you calculate the covariance. Okay. Alternatively, I can show you how to do this. So let me copy those numbers. This is actually a clever way, better way to do this question. So I will just copy the numbers to Excel and calculate covariance formula. Then you will get this number. Of course, if you extend number, you get exactly the same number. So you may do it by hand, like I did, or it is also okay if you use Excel. If you know how to calculate on Excel, that's enough these days. Okay. Next question. After analyzing several months of sales data, the owner of an appliance store produced the following probability distribution of the number of refrigerators and stoves sold daily. So that means for simplicity, I simplified the data like this. So on a day, 40% of days, there is no sales in refrigerators and stove ranges, 0 and 0. But on 20% of days, one stove is sold. On another 10% of days, only a refrigerator is sold. And if lucky, 30%, both refrigerator and stove are sold. So there are 4 different types of sales daily. We are going to find the covariance. By the way, when the probabilities are given, you cannot use Excel like this because this formula does not recognize the probability. So you may use Excel as a calculator, but there is no like shortcut, no one-shot formula to calculate this covariance. So you have to follow all the tedious steps like this. Basically the same 3 steps. Let me show you. So step 1, let's calculate the expectation. By the way, I am going to denote the refrigerator sales as X and the stove sales as Y. So X is either 0 or 1. You may sell this 1 or not. So refrigerator, 40%, these 2 types of days, you sell 1 refrigerator. So that is 40%. And the other 60%, the first 2 types, you sell 0. X is 1 with 40%, bottom 2, and 0 with 60%, the upper top 2 rows. So it is binary distribution. So the expected value of X, expected value of refrigerator sold on a day is 0.4. Similarly, stove is sold on these and these days, right? The second and fourth type of days. So the probability is 50%. Y is 0. Y is 0 on the first and the third type of days. So that is also 50%. So it is binary distribution with 50%. Therefore, the expected value is 0.5. Okay? That is how we calculate the mean. The mean is easy to calculate. And then from there, we are going to calculate deviations. It is either 0 or 1. So if you subtract the mean, it is either minus 0.4 or plus 0.6 for X. And for Y, the mean is 0.5. So it is either minus 0.5 or plus 0.5. So you get deviations for X and Y. And then multiply them. Multiply those deviations. So you get cross products. And then, so the next step, what we just got is, so remember we have 4 types of days, 4 types of sales, and for each of them, we calculated the cross products like this. Okay? So we can attach the probability to those 4 cross products. The probabilities are attached. Then you have to calculate the probability weighted cross products of the deviations. So you are going to multiply these, and these probability weighted products of deviations are summed. That is kind of the average of those cross products. That is the covariance. So therefore, the covariance is 0.1. Right? So that is complicated, but annoying, tedious, but this is how we calculate the covariance in this example. Next question. The following table gives the per capita income in $100 and the percentage of the economy represented by agriculture for some countries. So there are 5 countries, and you observe their per capita income in $100 and the percentage of agriculture in that economy, right? So you observe 5 and find the coefficient of correlation coefficient, and use the sample version formula. What I recommend here is you may go through this kind of calculation as the first question. You can go through these computation, but I would do it this way. So just as I did, like enter the numbers into Excel, and correlation coefficient formula is CORREL. So use the formula to obtain the correlation coefficient. It is 0.6875, right? I'm not going to explain how to calculate that. I'm not going to show you the algebra. So I recommend use Excel. Okay. Next question. In a course, the grade is based only on the midterm and the final exams. Suppose that the maximum possible score is 40 points in the midterm and 60 points in the final. So the maximum total score is 100 points. Some summary statistics on exam scores are as follows. Midterm exam mean is 30, variance 16. Final exam mean is 50, variance 25. Covariance between the midterm and the final exam scores is 15, right? Possibly correlated. So those who did well in midterm tend to do better in the final too, right? So we basically have all the information we learned in this course, right? All the summary measures are collected here. Determine the correlation coefficient between the midterm and the final scores. So simple, because we need to calculate correlation coefficient like this. So x is midterm, y is final. So correlation coefficient is covariance divided by standard deviations. Covariance is given here. Standard deviations can be calculated from the variances, right? Square root of the variances. So easy, you can calculate that. That is the correlation coefficient for the midterm and the final. Okay, that's it. Next question. The Graduate Management Admission Test, GMAT, has 4 sections. By the way, the exam could have been changed since I made this question. So, anyhow, it is fake data, right? The 4 sections: analytical writing, integrated reasoning, quantitative, and verbal sections. Suppose that a researcher collected GMAT score data and calculated the covariance matrix across sections, right? So there are 4 scores, and they are calculated. Their covariances are calculated. Then the question is to find the pair of 2 sections that have the largest correlation coefficient. Okay. So it is about the matrix, and you know the diagonal terms are variances. For example, 0.81 is the variance of analytical writing, and 9 is the variance of verbal section. So that means you can calculate standard deviations from those diagonal entries, right? By taking the square root, you can calculate the standard deviations, and we need standard deviations because we are going to calculate correlation coefficient from those covariances. So we know correlation coefficient. To calculate correlation coefficient, we need covariance and standard deviations, and covariances are here. These are covariances like 0.108 or 1.08. These numbers are covariances. So we need to standardize those covariances using the standard deviations. I did that. It's actually pretty annoying algebra, but definitely possible. So here, think about this. The correlation coefficient between integrated reasoning and analytical writing is the covariance divided by square root of the variance of analytical writing. And here, this is the variance of integrated reasoning, right? So this covariance is standardized by square root of this and that. Similarly, like if you standardize this covariance into a correlation coefficient, you have to use square root of this and that. Then you are going to get 0.5. So in the end, now you see how I made up the numbers. So the 6 correlation coefficients are 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So this is the answer. Largest correlation coefficient, right? I made up those numbers so that all the coefficients are positive and 0.1 increment. Okay, this is how you do it. Next question. A restaurant serves soup and salad. The soup sales increase in winter and the salad sales increase in summer. Some summary statistics on the sales for each menu on a day are given below. So 30 bowls of soups are sold per day on average, with a standard deviation of 3. Right? Mean is 30 and standard deviation is 3. 20 bowls of salads are sold per day on average, with a standard deviation of 4. So mean is 20, standard deviation is 4. Their covariance is -5, right? So as I said, soup selling well in winter and salad well in summer. And suppose that a bowl of soup is $4 and a bowl of salad is $10. Determine the covariance between the revenues in dollars from soup and salad. So this covariance is based on the number of bowls of salads or soups, right? However, we are now more interested in the revenues in dollars, not the number of bowls. Okay. Then you have to use this notation. X is the number of bowls of soup sold a day, and Y is the number of bowls of salad sold on a day, right? X is soup and Y is salad. And W, we transform X and Y into their revenue, W and Z. So W is 4 times X, Z is 10 times Y, because soup is $4 and salad is $10, right? So multiply the price. And then what we want is the covariance between W and Z, which are revenues. W and Z, and because W and Z are obtained by linear transformation, so we may use the relationship between the original covariance and the new covariance. So after linear transformation, the new covariance is multiplied by both multiplications, right? 4 times 10 times the original covariance. And we know the original covariance, so you can easily calculate the covariance of the new variable. By the way, these numbers are not used, useless numbers in answering this question. So 30 bowls, 20 bowls, standard deviations are not used at all. So they are just traps. Okay. Next question. In the history of NBA, blah blah blah. So basically, having 1-2 punches in a team can reduce the chance of inconsistent performance by complementing each other. So in NBA, like 2 star players can, if one does not do well, then still the other player can help. So there is just like that. And suppose that 2 star players in the same team, say A and B, have the following stats in a season. So player A's average points per game is 25, standard deviation is 5. Player B's average point per game is 20, and the standard deviation is 4. So, and the correlation coefficient between their points per game is minus 0.625. Interesting data, right? So that means when one player does better, then the other player does not do well. and vice versa, right? So they are not, they are moving in the opposite direction. Of course, the data are fake. I'm not certain if this is true in real data. Anyhow, so what we need to find is the standard deviation of the sum of these two players' points per game. So sum of two random variables is what we are going to look at. So define x is a plus b, right? And we are going to use this formula. The variance of a plus b can be written as variance of a plus variance of b plus 2 times covariance, right? This is the part. And then we only need to calculate the variance a, variance b, and the covariance. Variance a is calculated from the standard deviation squared. Variance of b is also from the standard deviation. And the covariance, you can calculate the covariance using the correlation coefficient and two standard deviations, right? Because correlation is covariance divided by standard deviations, you may move standard deviations to the other side to calculate the covariance. Then it is easy algebra. Just plug in those numbers and calculate, and then plug in those numbers back into this equation. Then you will obtain the variance of x, and then from the variance, you can calculate standard deviation by taking square root once again. Okay, that's how you calculate this. The last question. One of the major risks in the economy is the oil price. Many financial assets are severely affected by the oil price. Consider, I don't know, ER is missing. Consider a natural gas company and an automobile company. The natural gas company will be hit by a low oil price because the demand for natural gas will decrease as oil becomes cheaper. But the automobile company will benefit from a low oil price as more people can afford the cost of driving a car. The probability of the oil price next year is given by the following table. So simply, I will consider oil price goes down, goes up, or goes down or does not change, or up. So 25, 50, 25%. And contingent on the change in the oil price next year, the annual returns to the companies are expected as follows. So depending on the move of the oil price, natural gas company may be minus 8% or 6% or 12%, right? So when oil price goes down, natural gas company will go down too. And like this. But automobile company will do better when oil price goes down. But if oil price goes up, automobile company will go down, right? So their performance depends on the oil price. You are planning to invest 50% of your investment in the natural gas company and the remaining in the automobile company. So 50-50. What is the variance of your portfolio? Okay, this is very interesting question, but actually very difficult to handle. I will show you two Bayesian methods, and you may choose which way you are going to do. First one is my recommendation. Simply, you make a probability distribution table for the portfolio return, right? So, by the way, it's when oil price, I change it. When oil price goes down, natural gas goes down by 8, but automobile increases by 18. So if you invest 50-50, their average is 5. So the portfolio will increase by 5. And oil price does not change. Natural gas is 6 and automobile is 4. So again, the portfolio will see 5 on average. 50-50, right? But oil price goes up. Natural gas is 12, but automobile is minus 10. So if you take half and half, so you are going to get 1 in the end. And again, typo. So then, in the end, this is what we need. only this column is what we are interested, right? So take that column, portfolio return, and attach the same probability. So attach the probability of oil price. And then you get a full probability distribution table. From here, you know how to calculate the standard deviation. We practiced that in chapter 4. So I believe it should be easy enough. Especially this is easy because there are only two possible outcomes. 5, the portfolio return is 5 with 75%, but 1 with 25%. So use these two outcomes and probabilities to calculate the standard deviation. You can do that. Or you may use the covariance formula like this. You may use this. So then, once to utilize this formula, you have to calculate variance of A, variance of B, variance of covariance of A and B. So formula is good. It is correct. It is true. But the problem is you have to calculate this, this, and this. It's clear that this will be more difficult than method 1. So knowing the formula will be good, is good, but it is not that efficient way to follow this. So I recommend you to think about this one. But if you are willing, then you may calculate the variances and check if two methods have the same answer. They should have the same answer. Okay, this is the end of this quiz, and we only have one more chapter to go. I'm so happy. So you have done a lot, and let's do once more next week. Thank you for watching. See you later. Bye.